In this video, you will learn periodic variations in element properties. Okay, so from the previous lectures, we know that when n is equal to 1, or when n is equal to 1, or any number, what is the maximum number of electrons that can have? That is 2 times n squared. So when n equal to 1, the maximum number of electrons will be 2 electrons. When n equal to 2, that will be 8 electrons. 2 squared, 4 times 2. When n equal to 3, it will be 9, 18 over here. All right, so let's try to do something like this. That means, let's say I have an atom that is with 7 electrons. So it will have 7 positive inside. And how many on the first principal energy level? I will have 2 electrons here. How do I know that? Because the first level, n equal to 1, I can maximum have 2. All right, because totally I have 7. So what will be the second layer? The second layer over here, I will have 5 electrons. How do I know that? Because you need to add up to be equal to 7. 7 positive inside, there must be 7 negative outside. So I have 5 of these electrons outside here. Okay. All right. Now, if I have, for the next atom, if I have 8 positive inside, what do we expect here? 8 positive. Now I have 1 extra positive. Over here, there will be another electron. So I will have 6 electrons now. But each electron over here will be pulled by an extra positive force. That means all these electrons will be shrink a little bit getting in here. Why? Because each electron will feel the extra positive that is pulling them in. That's why when I increase by 1 electron, actually the radius of this atom will be decreased. If I put another one, so now I have 6 electrons here, I put another one here, so I will have 9 plus 1, I have 9 inside. Okay, so I have 9 electrons, 2 over here and 7 over here. So it will shrink more. If I increase by another one, it will shrink even more because I have so many positive inside and pulling the electron in. Okay, so that's why across the periodic table, going to the right side, you are going to see a decrease in atomic size. Over here, so let's look at this one. Going to the right side of the periodic table, in the same period, you see the atomic size is decreasing. Of course, sometimes there are exceptions, but we know the reason. Okay, now, what happened? If you have, now we have 10 electrons, if we have another one, because we have already reached the limit of going to n equal to 2, if I add another one, I cannot add to this principal energy level. The next principal energy level will be over here if I have to add one. Okay, in this case, if I go to the new level, look at the radius, it's much bigger. All right, so within the same principal energy level, if you add electron, you're going to make the atom smaller. But if you go to a new shell, and n equal to 3 now, suddenly look at the radius, it is much bigger now. Okay, so that's why when you look at the periodic table, going down the periodic table, you see that the radius of the atom is getting bigger and bigger because we have an extra shell to it, extra level, principal energy level. Okay, that means an extra layer. Now, let's look at the following situation. With the electron over here, we know that there are 11 positive inside. So this 11 positive is pulling it in. However, with this electron over here, it will also feel the 10 negative electrons pushing it. In other words, if we can draw an imaginary line like this, so the net charge within this area, it is just positive 1. So this electron can feel that over here, only one positive that is pulling it in, because there are 11 positive and 10 negative. So the net charge over here inside this great circle, it will be one positive net charge. And this is called the shielding effect. Shielding effect means the charge that's pulling it in, instead of 11 now, it will be the Z effective. That will be equal to Z, that is 11, minus the number that is shielding. Okay, so that means it should minus over here. So it will be 11 minus, in this case, is close to 10. So over here, the Z effective will be positive 1. That means this electron will feel only one positive is pulling it toward the nucleus. Okay, so now we know that across the periodic table, when we go to the right side, in general, we should expect the atoms to have a lower atomic size because it's pulling by the positive inside. And if we go to another layer, we add another layer, and when we go down, the atomic size should become bigger. Okay, it should increase the size in this way. Let's talk about the ionization energy. What is ionization energy? It is the energy that required to remove an electron from the atom or the compound. For example, let's say I have an atom, X. How do I remove an electron? Then it will become X minus positive plus an electron. Okay, so when I remove an electron, it should have a positive charge. And this process always will require energy. So delta H for this will be greater than 0 because it required some energy to pull an electron out from an atom. Let's look at this. If this is a nucleus with a lot of positive charge inside, okay, and the electrons are out here, the electron that is further away from the nucleus will be easier to remove. Why? Because it's just further away, and according to Coulomb's law, that means the force required to remove will be K times Q1, Q2 divided by R squared. Okay, so when R is bigger, it will be easier to remove that electron. And in general, if you go across the periodic table, let's say this is a periodic table, it will be very easy to remove the electron from here, and therefore the ionization energy would be very small for the one over here. It will be small for the first column because the first column prefer to be X1 positive. That means it will be very easy to form this one. It will increase going across the periodic table. The ionization energy going across will increase in this case, going across the periodic table. And in general, when it goes down the periodic table, the ionization energy will decrease. Okay. So here is a chart showing, okay, from hydrogen to helium that is going across to the right side of the periodic table, and the ionization energy will increase, and all of a sudden it go back to the first column, to the alkali, and it decrease, and across the periodic table it increase again, and once it go to the new period, the new row, it decrease and keep going like this. Of course, you can see some exceptions over here. It's not directly go up all the way. You always see some exceptions, but it doesn't matter. The trend is going cross to the right of the periodic table, it will increase, and going down, it will decrease. So that was the ionization energy. Something similar, what you can say is the opposite, which is X would become X minus. Okay, how I can do that? Because I have to force an electron over here. So add an electron on this side. And the energy for this one is called electron affinity. So delta H, in this case, it can be positive and it can be also negative.